Okay, today's lesson is called literal equations. So we're going to start by solving some really simple ones here in the beginning. These are actually normal equations where we just have one variable. So if we are going to solve this, we know that in order to get rid of that plus 3 that's being added to the variable, we need to do the inverse operation of addition, which is subtraction. So we're going to subtract 3, and I want you to write everything down exactly like I put it up here on the screen. We know that 3 minus 3 is 0, and therefore we're left with x equal to 6. Okay, so that's easy, all right? Let's go over here to number 2. If we're solving this equation, instead of an x, now we have a y, but we're going to do the same thing, right? We see addition, so we are going to subtract 3 on both sides, and we end up with y equal to 9 minus 3 is 6. So the question is, did it matter whether we solved for x or y? Does it matter that question 1 had you solving for x versus question 2 has you solve for y? Does that matter? It doesn't matter in those two examples because those are the only variables to solve for. Okay? But let's look down here in number 3. This says solve for x. It's very important that you read, don't just look at the equation, but find out what you're supposed to be solving for, because I could very well give you this same equation and say solve for q. It's all up to the person who's writing the problem. Okay, I can have you solve for x, or I could have you solve for q. That says x plus q equals 9. Okay, so I want us to solve for x. So the way I want you to do this, I want you to put an arrow over the x like this. That is going to help remind you to not mess with that x at all. Like, it needs to stay there. Okay, so what is happening to that x? Well, q is being added to that x, right? How do you suppose we could get rid of a plus q? Subtract q, right? Just like we subtracted 3 a minute ago. Okay, don't let the whole fact that it's a variable throw you off. Okay, so we're going to subtract q here. It means we have to come over here and subtract q, because what you do to one side of the equation, you have to do to the other side. All right, well, q minus q goes away. We're left with x equals. Now, this is where it can get a little tricky. Some kids are like, well, I don't know. We can't do 9 minus q because we don't know what q is, right? So you actually are just going to write 9 minus q. And that equation is now solved for x. Okay? Now, there is another way we could write that would be equivalent. So I want you to write or. Can somebody tell me another way we could write that would be equivalent to 9 minus q? Nolan? No? Bryson?
Q minus negative 9.
Be careful and remember that because of the commutative property doesn't work with subtraction. But if you took the sign that's in front of that q with it, you could switch the 9 and the q. So anybody want to do you want to take another shot at that? We are going to do what you said. We are going to switch them around, but the signs are a little off. Alexis?
Negative q plus 9.
Yes, ma'am. That is a minus q. That's a negative q, right? And that 9 is a positive 9. So another way we could write this is negative q plus 9. And I want you to have it, in your notes, I want you to have it both ways. It's very, very important that as we're working these problems, you understand that there are a variety of ways to write the same answer. Now, some problems I'm going to show you, I'm going to say I want it this way. Okay, so just pay attention to that. All right, let's go to number 4. Solve for x. So put an arrow over the x. So if we're going to solve for x, that means we don't want to mess with the x. We want to get rid of everything else that's on that side of the equal sign except for that x. So that means we want to get rid of that plus 2y. Not just the 2, the whole plus 2y. If we can remove that plus 2y right here from this side, then we will have x by itself, which is what we want. That's a plus 2y. How can we get rid of plus 2y? Minus 2y. So that's what we're going to do. We're going to write minus 2y on both sides. So now we have x equals, well, we don't know what y is, so we can't figure out that. We're just going to have to write it like we see it. Well, how do you see it?
13 minus 2y.
13 minus 2y. But for our notes, humor me, because it is important, and tell me, we could also write this as x equals, negative 2y plus 13. Very good. As long as you take the sign that's in front of it, you can move it around. You cannot just write 2y minus 13. Do you see the difference there? Okay, are we okay so far? Okay. Look at number 5. So this one doesn't say to solve for x. It says solve for y. So put your arrow over the y. Raise your hand if you can tell me what you think we should do here if we are going to solve for y. Abigail? Yes, add 6x. Come over to this side and add 6x. So minus 6x and plus 6x makes 0. That's what we want to happen. And we're left with y equal to, who can give me what we are going to write over here? Matthew.
Negative 5 plus 6x.
Okay, and who can give me the or? Clay?
6x minus 5.
Very good. Very good. Okay, now let me stop and say something for a minute. When we get to graphing, where we're graphing lines, when we're graphing lines, our equations will have an x and a y in them. And when we're graphing lines, we will always be solving for y. Are you listening? Today, you solve for whatever you're told to solve for. But when we get ready to start dealing with slope and graphing equations of lines, we will have x's and y's, and we will have to solve for y. And when we have to solve for y, and we go to write out the rest of that, I will want you to write it this way, the second way, where the variable comes, the term with the variable comes first. Okay, I will emphasize that when we get to that unit. Okay, all right. Number 6, solve for y. So take your little arrow, put it over the y. Okay, now this one's a little bit more involved. If we're going to solve for y, what things are we going to, I hate to say terms because one's a term, one's a coefficient. What do we need to get rid of from that side in order to get y by itself?
X.
Abigail? The x and good, the 2, right? Now, here's where it's very, very important. The question is, well, what do we get rid of first? Why the x?
Because you do the opposite of the order of operations.
You do, exactly. We have to do the opposite of the order of operations. Order of operations tells us to multiply, divide, then add, subtract, right? But when we're solving equations, we have to do the add or subtract before the multiplication or division. And that 2 is connected to that y by multiplication, right? So we can't do that yet until we get rid of this x.
We'll be printing interim soon, so do not send any jobs to the copy room copier, please.
Okay, so that's a positive x. Now, is this a positive x because of this plus sign? No, it's a positive x because in front of it, there is no negative, correct? Okay, so how do we get rid of a positive x or a plus x? We're going to subtract x here and over on this side. So we bring down my positive 2y. Now let me stop you too. If that was a minus 2y right there, you would need to bring it down as a negative 2y.
Wait, you said
If it was a minus 2y, when we come down here and we bring all of this down, you would need to write it as a negative 2y. Do you guys see that? Okay, be real careful with your signs. Okay, equals, what does it equal?
13 minus x.
13 minus x, okay. All right, well, we're almost done. Now, we could also write that as 2y equals what?
13 plus minus negative x.
Negative x plus 13, right? You could take that minus x and you could have put that first and then the positive 13. That's really important, guys, that you see that you can do that both ways. Okay. All right, we're still not done because we need to solve for y. Right now we've solved for 2y, right? That's not good enough.
Yep.
How is the 2 connected to the y? Multiplication. What's the inverse of multiplication? Division. So we are going to divide by 2. Now watch this. If we divide that side by 2, we have to divide this whole other side by 2. So we end up with y equals 13 minus x all divided by 2. Over if you were writing it this way, which I would really hope in your notes you're writing both ways down. Okay, so then let's divide by 2. So we come over here and divide by 2. Now let me show you something.
Oh, okay.
We could have done it over here. We could have written 13 over 2 minus x over 2. We could have broken it apart like that and put the 2 underneath each of those terms. Okay, we can bring all of this down just like it is, or we could write it this way. Negative, that's a 1x, right?
Yeah.
Negative 1x. We could write negative 1 over 2, x out to the side, plus, and then 13 over 2, which 13 divided by 2 is 6.5. You could write it that way. There's a lot of options here. Okay, and when we start getting ready to graph equations, we're going to have to write it this way. We're going to have to break it apart and put the denominator under both of those terms and simplify it as much as possible. Okay? All right. Number 7, solve for y. Okay? So raise your hand if you know what we should do first here. If we have to solve for y, what are we going to get rid of first? Raise your hand. Malin? Good. Get rid of the negative 4x. Whether the x is just an x or whether it has a number in front of it, which it really always has a 1 in front of it, right? It's just sometimes we're not going to see that. You need to get rid of that entire term, that entire negative 4x. So we're not going to just try to get rid of the negative 4 if we're solving for y. We need to get rid of that entire negative 4x. Okay, so how do we undo? That's like a minus 4x. How do we undo that? Add 4x here and over on this side. So we bring down positive 2y equals, okay, now we don't know what x is, so we can't actually add the 4x to the 10 because the 10 does not have an x. If the 10 had an x, that would be 14x, wouldn't it? Mm-hmm. But it doesn't have an x. So we have to write them out separately. And there's 2 ways we can do this. We know because we're getting the hang of this. We can write this as 10 plus 4x, right? Or we could write 2y equals what? 4x plus 10. We can write it either way. Either way. Are you guys getting the hang of seeing that it could be either way? Okay. That's so very important because here's a reason. Let's say at the end of the year when you take the EOC, you solve an equation and you get an answer. And let's say you did it right, but you don't see your answer as one of the multiple choice options. Maybe it's because it's written in a slightly different form. Maybe you did it right. But if you don't understand how equations can be equivalent and written in different forms, then you may think you did it wrong. Do you see what I'm saying? So it's very important that I teach you as we go through our lessons when there are different ways to write the same type of answer that I expose you to that. So that when you're working on your test at the end of the year for high school credit, which is so awesome, right? You're all going to make it. You're going to be fine. But you got to be aware of that. Okay, so let's finish this. How do we get rid of the 2? Divide by 2. Here, now listen, I'm going to just tell you, if I see over on this side that any of these numbers are divisible by what I'm about to divide by, I always write it under each piece. I don't just put divide by 2. I actually do this because I can see, oh, I'm going to be able to simplify that. Okay, so when I do, I get y equals what? 5 plus 2x, okay? So let's come over to this side and do the same thing. Divide by 2, and let's see what ours looks like over here. Y equals 2x plus 5. Well, we know those are the same, right? Because of the commutative property that says it could be 5 plus 2x or 2x plus 5. Okay? How are we doing? Are we doing okay? I'm trying to go slow because I know from experience, I've been teaching for 10 plus years, and this is always a very difficult lesson. But we're okay? Okay. All right. Take good notes so you can use them at home. Solve for y. Oh, this one's easy. This one doesn't have as much to do. Why? Because the y doesn't have a coefficient other than 1, right? Coefficient is the number in front of the variable. So all we're going to have to do is get rid of the what? The negative 3x. Now we do that by addition or subtraction. What do you think? Addition. So add 3x, and y equals,
5 plus 3x.
Or 3x plus 5.
good, or, and then don't just put or, I know you didn't mean this, but don't just put or 3x plus 5, right? Or y equals 3x plus 5. Please make sure you're writing it both ways in your notes. You don't really have to do both ways in your homework, although it wouldn't hurt you. It would be really good for your brain. But I definitely want it in your notes. Okay, and we're done because y is by itself, right? So we only had one step there. That's pretty easy. Okay, let's look at number 9. Solve for y. Well, there's a number in front of that, so that's going to be a little more work like the last one, right? Okay, raise your hand if you think you know what we need to get rid of first and how we're going to do it. And I want your hands up. I need to start seeing a little bit more involvement here so I know that you actually are understanding. Okay, Anthony?
We get rid of the 5x.
How?
We add 5x to 5x.
Thank you. Add 5x to both sides. So we have 3y equals, and we can write this as 9 plus 5x, or we come over here and write 3y equals,
5x plus 9.
good. You got this. Okay, and then one more step, divide by 3. Now, I see, do you see that 3 can go into that 9? It's not going to do much with the 5, but we'll be able to simplify it with the 9. So don't just write all of this over 3. Don't do that. In a case like this, I would prefer you to go ahead and do this so that you can simplify it and write 9 divided by 3 is 3 plus, and instead of writing 5x over 3, put 5 over 3 and put the x out to the side. It does mean the same thing. If the x is in the numerator, it's the same thing as having it out to the side. Okay? Or divide by 3 over here, which we already know what it's going to look like, right? Because we know how to switch this around. 5 over 3 doesn't simplify. X plus 3. Okay? Okay, let's look at number 10. Now we're back to super easy ones. We only have one variable. There's only one thing to solve for here, right? How do we solve this? Divide by 3. So x equals what? Negative 5. Okay? So if that's the case, then when we go over here to solve for x, what are we going to do?
Divide by y.
Yes, divide by what you want to get rid of. So you have x equals, and we don't know what y is, so it's just 9 divided by y. And that cannot be written any other way. That must be written that way. Okay, flip it over. Anybody know what that formula actually is? Number 14. What does that look like the formula for? Perimeter of a rectangle. Because you got 2 lengths and 2 widths, right? Maybe your x is your length and your y is your width. Maybe that's what it is. Okay. Solve for y. So if we're going to solve for y,
Wait, so we're not doing 12 and 13?
where did that go? Did I skip it? Oh, I'm so sorry. Yes, we're doing 12 and 13. We need to do that. All right, solve for x. I'm sorry. Oh, we just did one like this. So if we're going to solve for x, we're going to get rid of the y by dividing. So x equals z divided by y. That's it. There's nothing else to do on that one. Okay, look at 13. Solving for r. Okay, now let me ask you this question because it looks like there's a lot over here. How are the 2, the pi, and the r connected? Multiplication. So if I want r by itself, I need to get rid of the 2 and the pi. But because it's all multiplication, I can get rid of them at the same time. How? Divide by what? 2 pi. Very good. Here and over here. All right, so the 2 and the pi's are going to cancel, and you're going to have r, and then you just have c over 2 pi. If you want to write it that way, or if you want to write, if I prefer to always have my variable I'm solving for on the left, like this. I like it this way, but it means the same thing. All right, number 14. Now, back to this perimeter formula. Solve for y. Okay, so if we're going to solve for y, would you prefer to switch that around so the letter you're solving for is over on the left-hand side? Visually, that helps me. So I'm going to write 2x plus 2y equals p. And I'm going to put my line over my y there. Okay. So we've done lots of them just like this, but they had different numbers and different variables, but it's the same thing. What are we going to get rid of first? There you go. How? Okay, we're getting rid of the whole 2x. We're not dividing. Dividing is if you're just trying to get rid of the coefficient. Subtract 2x. Subtract 2x. So we have 2y equals, let's just pick one way to write this. You want to write p minus 2x? Okay. We've done enough writing it both ways. All right, now one more step. Divide by 2. Now, would I just write the whole thing divide by 2? I could, but I already see that I can divide 2 by the 2 that's in front of the x, so I'm going to go ahead and put it underneath each individual piece so that I can simplify. So y equals p divided by 2 minus what? X. There you go. Very good. I'm actually rather impressed. You seem to be following me okay. Maybe I'm getting better at teaching it. Maybe that's what it is. Poor kids I taught my first year. Oh. You know what's so funny is one of our substitutes today, I taught him in 9th grade. He's already graduated from college, so that's how old I am. Okay, solve for y. Now, we haven't done one like this. Anybody want to just take a guess at what you think we might do? Okay. Multiply by x. If we multiply by x, on this side, we're going to have x squared. So that won't help us there. We haven't done these like this at all. You want me to just tell you what to do? Okay. You can solve, these are called proportions. When you have two fractions with an equal sign in the middle, it's called a proportion. Okay, they're proportional. If we're saying these are equal to each other, then these are basically equivalent fractions is what these are technically are. And the way you can solve is you can use cross multiplication. So we can do y times 3, which is 3y. Put an equal sign, go the other way. X times 4. You always put the number in front as the coefficient. That's 4x. Now solve for y is pretty easy, right? What do we do?
Divide by 3.
Divide by 3. So we have y equals 4/3 x. You can write 4x over 3 if you want. I prefer it to be out to the side. It cannot go in the denominator. If it's in the numerator or out to the side, that's okay. But it would have to already be in the denominator to be okay in the denominator. It doesn't mean the same thing if it's in the numerator as it does in the denominator. But if it's in the numerator up here, it's the same thing for it to be out to the side. You guys follow that? Okay. I feel like I'm talking in circles sometimes. Okay, so we can do this one easy now, right? We're going to do this by solving for y. So I'm going to start with this pair. Okay, y times c. cy, I always do alphabetical order, equals x times d, dx. Solving for y, I'm going to get rid of my c by division. So I have y equals dx divided by c, or d over c with x out to the side, doesn't matter.
Would it matter if it's not in alphabetical order?
So like if you had y equals xd over c, it really is equivalent. Here's what's so important to me. As long as you understand they mean the same thing, I'm okay with it either way.
Okay.
It's if you don't understand that it means the same thing that will be the problem, and mainly because of what I said earlier about when you're taking some kind of a standardized test and you solve a problem, I want you to understand that you might have done it correctly and you need to find the answer that would be equivalent to your answer. Maybe you did mess the problem up. Maybe you do need to go back and rework it. But it's possible you did it right and you just need to know what answer it means the same as yours. Okay? All right, 17. All right, so we haven't done any of this. This has one variable. This is just an equation. We're just solving this equation. Here's what I would suggest that you do. I would suggest you put a 1 underneath that 7 and you solve it using cross multiplication. So x plus 6 times 1 is just x plus 6. Put your equal sign, go the other way. 2 times 7 is 14. Now this is super easy to solve for x. So we took something very ugly and very complicated looking, and we just made it a one-step equation, right?
Yes, sir.
Minus 6, so x equals,
8.
okay, not bad at all, right? You can handle that. Okay, let's do the same thing on 18. Put a 1 under here. Now, we do have two variables, so we are going to have to solve for x, but let's do what we just did. X plus y times 1, x plus y, equals 2 times 7 is 14. If we're solving for x, we're still going to get rid of that plus whatever, plus y, by doing minus y. So x equals 14 minus y. Or, if you wanted to, you could write x equals what?
Negative y plus 14.
Negative y plus 14. Okay, it can be either way. Okay, here we go. Another one. Put a 1 under, cross multiply. 6x minus 3y times 1 is just 6x minus 3y. Equals, what do you get the other way? 10. Okay, now we're solving for x, right? Okay, we always do addition and subtraction first. So get rid of the term that is not connected to that variable you're solving for. Save this number that's connected to what you're solving for last, because that's multiplication, right? And that goes last. So we're going to get rid of this. How? Add. It's always add or subtract. Add 3x.
3y.
Yes, thank you, 3y. I wrote y instead of x. Sorry, please don't add 3x. Add 3y. Okay, bring down the 6x equals 10 plus 3y. Or if you wanted to, you could have written 3y plus 10. Divide by 6. Now, I'm going to do this because I can see that even though it's not going to be a whole number, I could simplify, right? Okay, so I'm going to have x equals, not 10 over 6. What am I going to have?
5 over 3.
There you go. Very good. 5 over 3 plus 1/2 y. You could put 0.5 y. Yes, you can write 0.5 y or you can write 1/2 y. Either way. Okay, number 20. Solving for h. Now this one's kind of tricky. So if we want to solve for h, we want to get rid of the 1/2 and we want to get rid of the b. So, right, that is the formula for the area of a triangle. Very good. What do you think we could do here? Divide by 0.5b. You could do that. Let's. I wouldn't mark it wrong if you had done that. I'm not a big fan of decimals within fractions. Like a fraction that has a decimal in the numerator denominator. You're not going to see that often. You want to try to avoid that. So my suggestion here would be that because we are dividing, basically what you're saying is dividing by 1/2 b. I would suggest that we deal with the 1/2 first. Remember, you can get rid of a fraction by multiplying by the reciprocal, right? So let's do that first. So see, these will cancel. And you have 2a on this side equals bh. And then now let's get rid of the b now. How? Divide by the b. So you end up with h is equal to 2a over b. That just looks nicer than a over 0.5b. You're more inclined to see something like this than you would. You're not. Okay. All right.
If we would put it the other way around.
Oh, like this way?
Yes.
I personally like it this way better. I would never mark it wrong on your paper if you had it the other way. But yes, you can write it either way. Okay, are we ready for the last one?
Yes, ma'am.
This one is probably more involved one. Okay, solving for, well, it's going to be the similar concept. Solving for C. You want to flip this around now? Let's go ahead and do this. Write this and put the F on the other side, and then we're going to solve for C. That just looks better. And then maybe it won't be so bad. So, thoughts here? Bryson?
32.
Yes, sir. Subtract 32. Okay, so we have 9/5 C equals what? F minus 32. Okay, and then we still need to get rid of the 9/5.
multiply
Oh, sorry. Sorry. That's that wrong person. You misordered it. You're with yourself. Sorry.
by 5 over 9.
5 over 9. By what? What are we doing with 5 over 9?
Multiplying it by 9 over 5.
Multiply by 5/9. Now, how do we do this on the other side? Oops. What do you think we should do? How do I write it? Okay, so like this, right? I guess I'm more concerned with what you're going to do in the next step. So this is all going to cancel, and you're going to have C equals. But I'm wondering, are you thinking we're just going to write 5 minus 32 times 5/9 like this?
No.
Okay, good, because we're not. So what are we going to do?
32 over 1. 32 5/9 minus 32.
Okay, tell me this. What is the 5/9 being multiplied to? So when we multiplied that entire side over there by 5/9, you're saying we really are only multiplying the 5/9 by the 32? We're supposed to be multiplying the entire side, right?
Yeah.
By 5/9. Yes, parentheses. Put the F minus 32 in the parentheses with your 5/9 out front like this. Is that the last one?